Okay, in this question we want to find distance between 2 points. In last question we find that distance between point of P and this line is 3s square root 2 divided 2, and distance between P and this line is 3 multiple square root of 5 divided to 5. So we want to calculate this distance by another rule, another method, by finding the distance between point of P by line of x plus 2 by drawing a vertical line from point of P to line of f(x). So when we want to draw vertical line and line of f(x) cross in one point, we find that point, and then we get distance between point of P and crossing point, that is Q. Distance between P and Q is distance between P and line f(x). So for finding point of Q, we know that for finding line of vertical line, we know that tangent line of f(x) to tangent of vertical line equals to -1. So for finding vertical line, we use tangent line of f(x). Okay, we know that tangent of f(x) is 1 because is tangent of f(x) is coefficient of x, so is 1. So tangent of vertical line is -1 divided to tangent of f(x), that is -1. So we have a tangent of a vertical line and we have a point of P, so we can find equation of line, vertical line. So if equation of vertical line by point of P and tangent of -1 is -x plus 3. Okay, we have two equation of vertical line and equation of line, equation of line and equation of vertical line. So from these two lines we want to find crossing point, and so we equals f(x) and get x of crossing, and by set x in one equation we get y of crossing point, and so crossing point is q by 1 divided 2 and 5 divided 2. So we have Q and P, so distance between P and Q is distance between P and this line. So for finding distance between P and Q, we use this equation, x2 minus x1 power 2 plus y2 minus y1 power 2 square root of this. So we put x2, x1, y2 and y1 in this equation by P and Q, because P is for example is point of 1 and Q is point of 2, so x1 and y1 are as P and x2 and y2 are as P2. We put them in this equation as x2, x1, y2, y1, and when simple that equation, at the final we get 3 square root of 2 divided 2. It is same of last question. For finding distance between point of P from line of fx, we use equation and elements like another example. At first we should find the vertical line. Vertical line use get from tangent of a line of fx, and tangent of vertical and tangent of fx is -1. We find tangent of vertical line and we have P, so we can find the vertical line equation by put P as x 0.1 in equation. We have y minus y1 equals tangent multiple than x minus x1. So put x1, y1 and tangent, and we get at the final tangent equation of vertical line. So we have vertical line and or line, so we get crossing point from these two lines. Crossing point from these two lines get by making equals y of two line, and by equaling to y of two line we get x x of crossing point, and put x in one equation, one line, we get 1 or 2, no difference. We put x in line 1 and get y of crossing point. So we have x of crossing point and y of crossing point. It is crossing point, and crossing point and point, we know that distance between point of P until Q or crossing point is distance between P and or line. So we find the distance between two points for finding these 2 points, we put one of them as point 1 and one of them point 2. So it is x1 y1 and point of q, x of it is x2 and y of it is y2, and for distance with 2 points we use this equation and put x2 x1 y2 y1 from this, and by simpling this equation at the final we get 3 square root of 5 divided 5. So it is the same of result of last question.